What's up guys, Onmaths here and we're looking at accuracy. So this is all about rounding, estimating, but we're going to be spending quite a lot of, or 2/3 of the time on accuracy, on limits. So we'll look at that with Edexcel and AQA. But here's a standard estimation question, and this is normally found on the non-calculator paper. Sometimes it crops up on the calculator paper. And it's very explicit to say estimate, because this question shouldn't be a question 7 on any paper if you've got a calculator, but with a calculator it's slightly easier. So how do we estimate? Well, the standard rule for estimation is one significant figure. Okay, that's what comes up time and time again with these exams. So if we go through it number by number, I'm going to miss the first one deliberately. 3.9 is simple. To one significant figure, that's 4. And 8.12 to one significant figure, that's 8. Okay, and normally those two are the easy ones. However, what some people do is they think that this one here will be 23. So we've got to figure out what significant figures mean. So significant figures mean, and let's just draw out this number, that we put an invisible line down after the first digit that's not a 0, right? Down here. That cuts the number off. We look at this one to see whether it is 5 or more. It's not, so that's going to stay a 2. All the numbers to the right turn into 0. Okay, but we don't need to write the 0.0 because it's not actually a placeholder, so it just sits at 20. So 23.1 to one significant figure is 20. Okay, then we can work it out. 20 times 4 is easy, 80, and 80 divided by 8 is just 10. So the point of estimation is it gives you a rough answer. If you were to work that out on a calculator, you will get an answer that's very, very close to 10. If you worked it out on a calculator and you got 106, you'd instantly know that you'd made a mistake somewhere. Okay, and that's kind of the point of estimation. And this one significant figure rule, unless it states otherwise, always stick with that rule. Always do it to one significant figure. There's a few exceptions. For instance, if you've got, I don't know, root 80, 0.2 or something, you wouldn't round that to 80 because 80 is not a square number. You'd kind of round that to 81. Okay, because then you know it's going to be 9. So there are some exceptions, but the general rule for this type of question, one significant figure. Next up, AQA, and these next two questions are all going to be about finding error intervals and understanding kind of the reverse of rounding, what the number could have been. So the simplest thing to do with this is just to draw yourself a straight line. Okay, we know when this was rounded, it was rounded to 6, but what's the next number down that it could have been? Well, the next number down it could have been is 5. What's the next number up it could have been? Well, 7. So where's the cutoff point between those? Where did it suddenly turn from 5 to 6? Well, it's here, and that would be 5.5. I'll switch to the pen. 5.5, right? Where's the cutoff line between 6 and 7? Well, it's here, okay, which would be 6.5. Okay, and those are the bounds, right? The lower bound is 5.5, the upper bound is 6.5. Okay, now if it was 6.5, if it was exactly 6.5, it would round up to 7. So that's why this symbol here doesn't have a line underneath it. But if it was 5.5, it would have still rounded to 6, so there is a line underneath there. It's a bit small, but it is there. So it looks like this close up. The other one, this one here, just looks like that because it can't equal it. Okay. Right, the next question says that a length of a second pipe is 4 meters to the nearest meter. The total length, Ollie says the total length is 11 meters to the nearest meter. Give an example how this could be correct. So if we add them together now, 6 and 4, we get 10, right? So we need to somehow get a little bit more out of them. So what's the maximum that first pipe could be? We've already said it's 6.5. Now some of you are going to say something, but I'm going to ignore you for a second. And have a look at this next one. So it's 4 meters. So if we were to do the same process again, draw a line, 4 in the middle, the next one down 3, that's 5, halfway between 3.5, halfway between 4.5, right? So the biggest that could be is 4.5, right? So if we do 6.5 plus 4.5, that is 11. Perfect. So we've answered it. So some of you might say, hang on, you just said it couldn't be 6.5 because that would round to 7. Yes and no. Okay. If you want the short answer, just accept the fact that you can still use 6.5 for continuous stuff like measurements. If you want the long-winded one, very, very quickly, the biggest one it could be is 6.49 recurring, right? But 6.49 recurring is equal to 6.5. Therefore, mathematicians just kind of accept the fact that 6.5 kind of rounds to both 6 and 7, okay? Now, if you were, I don't know, a little bit nervous about writing that down, probably with good reason, you could actually write 6.4 and 4.4. That's the acceptable answer because if you add those together, you get 10.8, which then rounds to 11 because he's taking the nearest meter. So that's absolutely fine, and that's absolutely fine. But I do accept those of you who say 6.5 is not acceptable, but unfortunately, a kind of a higher level of maths backs me up on that. Just trust me. I've saved the more difficult one till last, although we've kind of probably got halfway there with the AQA question. There's kind of no training wheels with this. The AQA one gave us a nice little framework to do it in. Edexcel are less generous and just give you these kind of dotted lines here, and that's it. So we've got the same deal as the AQA question. So if I start filling it in, this time it's to 2 decimal places, which shouldn't make us nervous because the next one down, well, 4.76, the next one down would be 4.75, right? Next one up would be 4.77, okay? And the halfway point between those, slightly harder, isn't it? Not that hard. 4.75 and 4.76, well, that would be 4, in fact, let's use the same colour, 4.755. Right, the next one up, so halfway between 4.76 and 4.77 would be 4.765, right? So we know that we put the 4.755 there, and we know we put the 4.765 there. It says that the error interval we're using the letter n, so we'll put an n in the middle. Now, just as I said with the AQA one, the inequalities will look like this, but it can be equal to 4.755, so we put a line underneath that, but it can't be equal to 4.765. It's everything up until that point, ignoring what I just said with the AQA question. Okay, so when you're answering this question, it has to be that way around. If you don't put the inequality signs exactly as shown here, you will not get the mark. So just make sure you have them. Essentially, you can just kind of learn this bit. Right, the letter might change. They do normally use n, but the letter could change. But just learn that every time you see an error interval, every time it asks for that, you're going to have those inequalities there, and you're going to just draw this little number line, bung that number there, bung that number there. Jobs are good. Well, I hope you enjoyed that video. If you found it useful, please click like. If you want to see more from us, we release videos every single weekday. That's Monday to Friday. Just click subscribe and click the bell icon to keep yourself up to date with all the videos we release. If you haven't already, which I'm sure you have, check out our website onmaths.com. Loads and loads of free resources there, and there'll be a card that magically appears above me now. Otherwise, keep your comments coming in. Very, very useful comments, and actually very nice comments on previous videos. So please feel free to suggest anything. If there's any topic you want me to cover after the current summer school series videos are done, then please suggest them. I read every single one. I don't necessarily reply to all of them, but I do read them. So please keep them coming in. Otherwise, thank you very much, and I'll see you tomorrow.